Dear students, I am going to prove third theorem on limit superior and limit inferior. In this theorem, statement says that a sequence an converges to L if and only if limit superior of an and limit inferior of an both are L. They will be same if sequence converges to L. Fine. Now, the condition is necessary part. Suppose sequence converges to L. Suppose sequence converges to L, then obviously we can find here if sequence converges to L, that means we can find for all epsilon greater than 0 there exists a positive integer m belongs to n such that an minus L is less than epsilon for all n greater than equals to m. That means infinitely many terms when you open this inequality. So we get here is L minus epsilon, here is L plus epsilon. So infinitely many terms are laying here. Infinite. Only finitely many terms which are n from 1 to m minus 1. These are finite. Only finitely many terms, they will not satisfy this condition. They will be outside this. Infinitely many terms are laying in this neighborhood. And that's why L is a limit point. So L is the limit point. L is the limit point of this sequence. And uniqueness part, we have already proved this theorem earlier. You can see that theorem which says that if limit of an is L, then L is the unique limit point. We have already proved this theorem. So just see that proof. So when L is the unique limit point, so obviously L is the least as well as the greatest limit point. क्योंकि एक ही है limit point, तो वही छोटा भी होगा वही बड़ा भी होगा. So L is the greatest as well as smallest limit point of an, and hence limit superior of an as well as limit inferior of an is L. Fine. And the uniqueness part, and this we have already proved in a theorem. Just see that theorem. Fine. Now here the sufficient part. Sufficient part is, suppose this condition holds. Limit superior of an is equal to limit inferior of L. Now we have to show that limit of an is actually L. L is the limit of the sequence. So we shall show that limit of an is L. Now let's suppose epsilon be greater than 0 be given. Now since limit superior of an is L, then use the theorem number 1 जो मैंने आज पहले पढ़ाई है regarding the limit superior, which says that, क्या कहती है वो थ्योरम रिगार्डिंग द लिमिट सुपीरियर? ये वो थ्योरम थी उसका पहले स्टेटमेंट कि अगर ऐसा है सो u प्लस एप्सिलॉन से कम जो है वो इनफाइनाइटली मैनी टर्म्स होंगी. हियर देयर आर फाइनाइटली मैनी टर्म्स विच आर ग्रेटर देन दिस नंबर. सो an इज लेस देन l प्लस एप्सिलॉन फॉर ऑल एक्सेप्ट फाइनाइटली मैनी टर्म्स. दैट मीन्स इफ यू ड्रॉ दिस, सो हियर इज दिस लिमिट l minus epsilon l plus epsilon. So here in this band there are only finitely many terms which are greater than this number. Infinitely many terms are laying because they are finitely many terms. So suppose they are m1 number of terms. So let us draw this m1. 1 to m1, these are finitely many terms. They are laying outside this. Outside this, that means they may be here. They are greater than this number. And rest of the terms, they are laying inside this. They are infinite. They are infinite. Only finitely many terms are outside this. This is the from the theorem number. This is the from limit superior. So they are m1. There are m1 number of terms from 1 to m1 which are not satisfying this condition. They are greater than L plus epsilon. Fine. Now limit inferior is also L, and according to this an is greater than L minus m. This is the limit regarding the limit inferior. This limit inferior means these two conditions are satisfied. Then according to the condition number 2, here are infinitely many terms which are greater than L minus epsilon, but only finitely many terms which are less than L minus epsilon. So now just draw this on this here. So this is L minus epsilon, which says that here are infinitely many terms, only finitely many terms are outside this. So suppose they are m2. they are here, they are less than this. They are only finitely many terms, m2 number of terms. They are less than this. However, infinitely many terms are greater than this number here. Fine. So when you take the maximum means according to this graph m1 is the maximum one. So if you take this, then obviously this neighborhood contains, this band contains all the infinitely many terms. Here m is the maximum of m1 and m2. This band contains infinitely many terms, and that's why L will be the limit. So this is here. So suppose an is greater than L minus epsilon for all except finitely many values of n, and suppose these number of terms are m2. So an is greater than L minus epsilon for all n greater than equal to m2. Now take the maximum of m1 m2, which is denoted by m. So now we can say that L minus epsilon less than an is less than L plus epsilon for all n greater than equals to m. That means this number is m. This number is m here, this number. So all the terms, they are laying in between L minus epsilon to L plus epsilon. So this is written here. And that's why limit of an is L. And so we can say that L is the limit of the sequence. Fine. So these are three theorems on limit superior and limit inferior. Thank you.